Going on now to topic 2.2 of Learn. We'll start this here very shortly. Again, you want to take good notes, but one of the items I will be asking about is how to solve an equation. What's the protocol for it? And I was reminded that sometime in the past I did a little lesson using the whiteboard for this. So we're going to revisit. Now here I used another textbook, so the topics were lined up differently, but I do want you to write in your notes what we have listed to the right of this whiteboard, and I'll take a few moments to go over it. So, how to solve equations. Now, this is just an outline of the protocol to follow. But step one, after you write it down, are there any fractions? Well, get rid of the fractions. And we'll illustrate that process as we go on. Item two, get rid of grouping symbols. Parentheses, brackets, again, fractions, the fraction bar is a grouping symbol. Now, then you're going to combine like terms, and we've done some work on what like terms are. Now, for item 4, isolate the x so that eventually on one side you just have a 1x, or we don't write the 1, the plain x, and on the other side you have a number. Now, the method for doing that, and we'll be introducing that in this section, is transposition. You could also use the additive inverse. The multiplicative inverse, that was the reciprocal that we illustrated in the earlier section. And if there's something else other than a 1x there, you're going to divide by the numerical coefficient of the x. And again, sometimes this might be the reciprocal, the multiplicative inverse. So eventually you're getting x by itself, and that's going to equal some value. Now, as you put your work into the software, you'll find that there's a check. You get to see whether or not it's right or not. If it's on a test, we would suggest that you do the check. Now, if anyone's interested, I'm going to put a little link to this up at the upper right corner, a circle with an eye in it. You can click and you can actually view this when I did some board work about 6-7 years ago. So the objectives will pick up as we move along. Now, the Learn also has a written sequence of steps to follow in solving an equation. You can pause and read this, but it's similar to the outline I've given you. So for example 1, take a moment, write the example down, and we'll go to the whiteboard. Now, as we see it, there are no fractions. There are no grouping symbols. We don't have to combine any like terms, so we're going to start to isolate the variable on one side. So we have a positive 3. Well, the additive inverse is a negative 3, and we do that to both sides, and we then get 3x, these cancel out, equal a negative 21. Now, we have a numerical coefficient with the x, which is actually 3 times x. We get rid of that by dividing by the numerical coefficient. And what we do to one side, we do to the other. These cancel out, make a 1. We get x then equals a negative 7. And as we go back to the board, we see that is our answer. In example 2, again, take a moment, write it down. We'll go to the whiteboard. And again, there are no fractions. There are no grouping symbols, but can we combine like terms? Yes, so let's do that. Negative 26. Now we have a positive 2y and a negative 4y will leave us with a negative 2y and a minus 14. And we want to get all of our letters on one side, all of the numbers on the other. So using this technique of the additive inverse, we'll add 14 to this side, add 14 to this side. We then get a negative 2y equals a negative 12. Now, again, we want to isolate the y. So we're going to divide by the numerical coefficient, a negative 2, both sides. You need to be careful of the signs. So this will give us a positive y equals 6. And there's the protocol following the steps we've mentioned. And going back to our board, we see we got this for an answer. Now, for example 3, again, you're going to write the example number down, and you're going to check that you've copied the example correctly. Now, does this have fractions? Well, yes, this has a special kind of fractions that are decimal fractions. Now, after inspection, I realize that I don't want to deal with all these decimals. So is there a way to get rid of decimals? And the answer is yes. So notice this term has 2 decimal places. This term only has 1, but I could add a 0 so that it does now have 2. This has 2 decimal places. This only has 1, but I could add a 0, and now each of my terms have 2 decimal places. So, what's the protocol of getting rid of decimals? Well, it's to multiply each term by 10 if it's 1 decimal, 100 if it's 2 decimals, 1,000 if it's 3 decimals. So multiplying each term here by 100, all I do is move the decimal place over 2 places. That's why I had to add that extra place. So I've rewritten it without the decimals. Now I'm going to collect like terms. I'm going to subtract this from that, and I get 1030, bringing my other terms down. Now to isolate the z's on one side, I'm going to subtract the additive inverse of this and get to this stage. Now, what happens here? Well, I'm going to divide by the numerical coefficient, both sides. And then this cancels out, and I end up with a z equals, this is going to become positive, and actually that's just 1/2. So going back to our board, we see our answer is, and if I go down a little bit here, I see it's 1/2. So again, much easier without the decimals. Now sometimes you can leave them if it's not too tedious, but this is the protocol for getting rid of those fractions that are in decimal form. So this is not too long. We're going to skip examples 4 and 5. So example 6 is our next one. And as we go to the whiteboard, you want to copy it down carefully. And then after study, what would you do first? Well, there are no fractions. There are no grouping symbols, but we can combine like terms. So that's what we do. So 4x minus x gives me a 3x on this side plus 1. And on this side, 2x. Now we have a negative 13 and a positive 5. Leave me with a negative 8. So this is often the middle step in your sequence of solving equations, where you get a variable and a number equals a variable and a number. And you want to try to keep your variables positive. So what would you do here at this stage? Well, I'm going to subtract 2x from this side and 2x from that side. And I now get x plus 1 equals a negative 8. And how do I get rid of the 1? I subtract the 1 from both sides, being careful of the signs, and I get x equals negative 9. And if I go back, I see that's what they've done. Now, once again, they are featuring the horizontal method. I like the vertical method, but you could use either one. Now we will skip number 7, going on to number 8. Now, are there fractions? Well, very definitely. So what's the protocol to get rid of fractions? We did this a little bit in an earlier lesson, but let's go over it in some detail. First, how many terms are there? Well, this is one term, one term, one term, one term. So 4 terms. And what is my least common multiple that I would multiply each term by to get rid of our denominators, our fractions? And you might say, well, you could use 30, but 30 is not the least. You could actually use 15, because multiplying each term by 15 gets rid of our denominators. So let's do that. So 3 goes into 3 once, 3 goes into 15 5 times, so 5 times 1x is 5x. Now 15 goes into 15 once, so this just becomes 13. Now 5 goes into 5 once, 5 goes into 15 3 times, so 3 times 3x is 9x. And then here, remember, there's a denominator of 1 already, so it's 15 times a negative 1 is a negative 15. So now you're dealing with a much easier equation. It's not the same, but it's equivalent. You've made it bigger, getting rid of all the fractions. So now we want to isolate the x's and trying to keep them positive. So after study, I think I will subtract 5x from this side, subtract 5x from this side, so I now get 13 equals 4x minus 15. Now, how do I get rid of the 15? Well, I'm going to the negative 15. Add 15. Add 15. I now get 28 on this side equals 4x. Now I'm going to divide by the numerical coefficient of the x, which is 4, to isolate the x, and I get x equals 7. Again, I had a rather difficult example, but by getting rid of the fractions, which is step 1, general form of solving an equation. And let's check it out. And if I bring this up a little bit here, We see our x equals 7, and they've done a similar protocol. Moving on to example 9, and you see there are no fractions, but there are grouping symbols. So our protocol is to get rid of the grouping symbols. So again, copying it down carefully, and then now you're going to distribute. Negative 2 times 5x is a negative 10x. Negative 2 times a positive 13 is a negative 26. And then we have a negative 2. Getting rid of our grouping symbols, distributing that's negative 6. This gives me a negative 18x and a positive 12 and our negative 41. So our third step is to group like terms. So that's what we're going to do. We get a negative 10x and a negative 28 equals a negative 18x, and then a positive 12 and a negative 41 gives me a negative 29. And you should check your math. Now, at this time, we're going to introduce two terms that I'd like you to write down. Transpose, and another form of it, transposition. Now, what is that? Well, this is a shortcut we often use in solving equations. If we want to remove a term from one side, we can just take it and physically move it to the other side. And when we do, when it crosses the equal sign, the sign of the term we're moving changes. So, for instance, we're going to take this negative 18x, move it to this side where it becomes a positive 18x. Do our subtraction here, and we're left with 8x on this side. Now, we want to get rid of this negative 28. So transposing it, that is physically taking it from this side to this other side, it changes its sign. It goes from a negative 28 on this side to a positive 28, and a negative 29 gives me a negative 1. Now this is a shortcut, and it's a shortcut for just adding the additive inverse. We've added a positive 18x on this side. That's what we've done on this side. But sort of eliminating that step and doing it mentally through this process. So now what does our x become when we divide by the numerical coefficient to isolate the x? X is a negative 1/8. And that's our answer. Let's check it out here. And bring this down or up, or however you look at it here. Let's see. There it is. Okay, hopefully some good notes and a shortcut. Now we're going to skip example 10. So you can write that you skipped it or just don't put it in your booklet. But now I want you to write the word background. Now for this background, we want to go over 3 types of equations. So one type you're going to write is the conditional. Now, what is the conditional? Well, so far, that is the kind of equation we've dealt with. That is, there is one answer that makes the equation true. true. So you're writing the word conditional, and it has a finite number of solutions. That is, in this case, it's 1. That's finite. Now, for the identity, and again, you're going to write the word down, identity, and I want to show you what an identity is. So take this down as well. 2x plus 1 equals 2x plus 1. Now notice what's on the left side is the same that's on the right side. So this is an identity. Now if you subtracted 1 from both sides, you would then have 2x equals 2x. So no matter what value you put for x on this side, it would have that same value for x on the other side. So all real numbers would make this true. So for an identity, the solution is an infinite number of solutions. That would be one way of describing it. Or another way, and write this down, all real numbers. And again, you may have to pause as we go on. All right, now let's do the third one, which is called a contradiction. Now in a contradiction, it looks like an equation, but actually there are no solutions. So what would be an example of that? Well, again, write this down. 2x plus 3 equals 2x minus 5. Okay, now notice if we subtracted 2x from both sides, we'd end up with 3 equals a negative 5. Now, is that a true statement? No. So, no matter what value you put for x here, this is never going to be a true statement. That's why in a contradiction, there are no solutions. Now, let's see a few examples of this. Now, for example 11, write this up. Here is our basic equation, and we'll just go through the process of solving it. We want to determine which kind of equation is this. So 3x plus 15 plus 1 equals a negative 11. Group like terms, 3x plus 16 equals a negative 11. 3x equals, transposing this, becomes a negative 16, a negative 27. Divide both sides by 3. X equals a negative 9. So it has one unique solution, a negative 9. So therefore, this is the conditional. For example 12, we've written it out. We're going to clear parentheses. 3x minus 75 plus 3x equals 6x plus 60. Group like terms, we get 6x minus 75 equals 6x plus 60. Now, if we subtract out the 6 x's, we end up with a negative 75 equals 60. Is that a true statement? No. Therefore, this example is a contradiction and has no solution. Then you might say, well, why did it even look like an equation? Well, it had the equal sign in it. All right, let's go on. One more, and then we're finished. Now, in our last example, Again, example 13, write the equation. We're going to get rid of grouping symbols. This is a negative 2x plus 14 plus x equals 14 minus x. Well, when we group our like terms on this side, we get a negative x here plus 14 equals 14 minus x. Now, notice if we add an x to both sides, we get 14 equals 14. Is this a true statement? Yes. So therefore, no matter what value you put for x on both sides, it's always going to be true. This is an identity. So the solution is, and let's go down to see that, there is an infinite number of solutions, or another way of stating it sometimes is all real numbers. Okay, this was a little long, but lots of good material and background to develop your skill for solving equations.